I want to talk a little bit about notches. Now, I've drawn 3 pictures of notches on the board here. Why do you put a notch in a tree? For direction. Essentially, it's the direction of where you want the tree to fell. We have got felling marks or black lines on the saw, or lines embossed in the saw all around the saw, such that if I want the tree to fall right up the middle, it starts by aiming your felling lines where you want the tree to go, if you will. That starts the first part of a notch, if you will, is direction. Do you understand this statement? If I say the notch is the front line of the hinge, do you understand what that means? Because if I've got a tree here and I have no attachment, if you will, to it, and the tree is leaning to the left a little bit, it invariably is going to go to the left, or leaning to the right, invariably could go to the right if I don't have an attachment point, like my elbow, to draw it exactly where I want it to go. So it's important that you understand that a notch alone is not, you're not complete. You need to have a notch and a hinge. Now, this first notch here is what you typically refer to as a standard, common, or conventional notch. It starts with a top cut into the wood about 1/3 of the way, if you will, at a 45-degree angle. You then make the bottom cut. As a rule of thumb, you make the bottom cut with the lay of the land. In other words, this is on flat ground, if you will. This might be on steep terrain or hillside, if you will. So a minimum of 45 degrees. You want to cut this notch and create what's called a clean apex. You do not want to bypass the cut. In other words, where the top and bottom cut come together, that is the apex. That needs to be very clean and precise. You don't want to have the saw run underneath and create a bypass like that. You have to then go back in and clean that up so it's clean where they both cuts come together, if you will. Now, I'm not a big fan of the standard conventional notch for cutting on the ground, because essentially what happens is the tree gets to 45 degrees, and then what happens to my notch? Yeah, the notch closes, okay? So when it closes, it puts pressure on the stump or the stem, and it tends to seek the stump, and you can see you get a lot of butt rebound, or a lot of the butt end of the tree coming back off behind the stump. So Rule 101 is never stand behind the tree when you're felling the tree. So to help you with this notch closing, because you don't want that tree to break at 45 degrees, because then it's going to go in the direction of the lean. It's not going to end up going where you want it to go, or it's going to sweep off the back of the stump, and that's not a good situation either. So what you want to do when you're making your back cut or your felling cut is you want to make this back cut from the back 1 inch to 2 inches above the apex, because that creates a stair step, or what we call a stump shot, so that as the tree is going, it tends to push on the back of this stump, and it keeps motion of the tree going forward. Very simple, the right thing to do. This is a Humboldt notch. It's a 45-degree standard notch upside down. It was developed in Humboldt County, California, primarily because of very steep slopes and felling trees on steep slopes. The other advantage of this when you're cutting big trees in Humboldt County, California, is that the notch wood on this conventional standard notch just sits on the shelf, and there was as much work, could be as much work getting that notch wood out. Those notches weighed 800 pounds, some of them, and up. So they made this upside down so that the notch would just slide out of the cut, and you didn't have to deal with all that extra work. Now, the same rule applies, though I'm not as big a fan of this, is because the tree at 45 degrees, the notch closes, if you will. So you still have to create a back cut that is elevated the apex by 1 inch to 2 inches to create this stump shot, if you will, so that the back of the tree lodges on that, keeps motion going forward. This is the notch that I use almost all the time. It's an open face notch. It essentially takes a 45-degree notch and opens up the face to 70 degrees or more. The reason for that is that the tree then gets past 45 all the way to 70 to 90 degrees, which means the tree is on the ground before it creates pressure at the base and it has more control. It allows the notch to work farther, if you will, as the tree is going versus having it stop at 45 degrees. Now, this would be an open face notch on level ground, and we actually have a nice design feature into the saw that way. When you hold the saw, it literally puts that bend of that blade at about 70 degrees. So all I gotta do is hold it in the bend and aim where I'm cutting my notch, and then cut into the tree till I'm about 80% across the face, if you will. So this would show you that you're on level ground, if you will. The nice thing about this as well is you're cutting more down the front of the tree. You're not cutting as far into the tree, and which keeps the cut, if you will, more into the sapwood. Now, if you're looking down through the top of the tree down, this would be the notch that is cut out. You would cut this top cut until you're about 80% of the diameter of the tree, if you will. You don't want to cut to your 100%, because that means that that hinge wood is going to be all the way halfway through the tree, if you will. So we want it to stay out front, if you will, out of the heartwood, more into the sapwood, which is the strong living fiber, very, very strong fiber of the tree. So 80% across. That also keeps my hinge more into the sapwood, if you will. So that's your cut. If you were making the open face notch on a hillside, it literally would be just angling that bottom cut downwards, so that you match the slope of the terrain so that the notch face closes after it's on the ground down the hillside. Remember this as well, when you're dealing with trees that are leaning backwards and you got to pull them up and over or wedge them over or machinery or rig them over, however you use them to get them to go over top dead center, you must make that notch larger, because you could literally, by pulling the tree up, eat up your 45 degrees of notch, and the notch is closed and the tree is vertical. So you really have to have this opened up a lot more so that you can allow the hinge to work after the tree goes over top dead center. So you'd want to have that open this way, very similar to what you got down there. Now the nice thing about this is that you can make this cut now equal or elevated by 1 inch to 2 inches above the apex, which gives you some margin of error. It's a little bit easier to do, can show you outside. It's also a lot more helpful to use that when you're using big trees and making cuts from the back on the big diameter types of trees. That tree now gets all the way down to the ground, the hinge works all the way, the notch face stays open, and everything is good. We have direct control all the way down. Now, we've talked about the hinge. The hinge is the uncut wood behind the notch, if you will. So in my first diagram here, it would be something that looks like in this area here. This would be your uncut wood, because without a hinge, you don't have any control. It doesn't allow the notch to work all the way, the tree all the way down to the ground. So you must leave a certain amount of wood. The calculation for that hinge wood, if you cut from the back, whatever you're doing, you have to leave a certain amount of that. The formula becomes 10% of the DBH. Now, DBH is an acronym for diameter breast height. That's a measurement at 4.5 feet above the ground, because you largely get above the root flare up into what is the measurable part of the tree based on its age and so forth. 10% DBH. So if I have a tree here that's 10 inches wide at 4.5 feet above the ground, 10% of 10 inches is 1.0, 1 inch. So you'd want this to be 1 inch as it is, uniform to 80% the length all the way across the back. Now, the traditional way of doing this is to cut from the back until you get up there to your hinge size, chain break, and get into your escape route. We'll talk more about that later. What I propose to you is this. The hinge, to most people, is the most important part of felling a tree. So when you're cutting the tree from the back, you're setting up the hinge last. As opposed to, we talked about those reactive forces. If I try to go through this tree with the top corner, it's going to kick. But if I try to go through with the bottom corner, it'll allow the reactive force of pull on the bottom to go right through the tree. I can then go up and make my hinge, come to the back, and leave a little piece of holding wood here. That gives me added time to look at my crew to judge where they're at, or environmental conditions or wind. I then just cut the back piece of that just prior to my escape or planned retreat, And I have a very, very good fell because the hinge is made first, which is the most important part, instead of me cutting from the back to the front. We'll talk about this again. 85% or higher of injury is related to 15 feet to the stump. So if I'm cutting from the back to the front, I'm cutting directly under where I'm at. I have a very, very high incidence of injury. If I cut through the center, make the hinge first, leave a piece, I can extend my retreat, check my crew, check the weather. I can clip that piece and the tree falls very quickly, and I have great control because the tree hinge is set at the perfect size and set right at 10% of the DBH.